Hello, in this video I'm going to solve question number 2, problems set to lecture 3, lectures in elementary number theory. Let a and b be integers such that 11 divides 2a minus 3b. Show that 11 divides 7a minus 5b. Pause the video at this point and give it a try. Okay, now let us solve this problem. I want to use the theorems that I have introduced in in lecture number 3 on this playlist, elementary number theory playlist. We know that a and b are integers, so that this combination is divisible by 11. We want to show that this combination is also divisible by 11. Okay, the theorem that I introduced in lecture number 3 was this theorem that if you have a divisibility relation that you know it is true between integers a and b, if you want to, you can add any integer multiple of the left-hand side to the right-hand side. Then you get a new divisibility relation. Let us say that multiple is m. So I keep a the same. I add any integer multiple of the left-hand side. Let us say m times a to the right-hand side. Then I get a new divisibility relation. The theorem claims that if this is true, and this theorem was also the other way around. If this is true, you can eliminate any integer multiple of the left-hand side from a divisibility relation. What is left for you is still true. Okay? Okay, so for example, here, I start from this assumption. The simple way to calculate, to solve this problem is to multiply the right-hand side by 9. Okay? Of course, if you do a little bit of practice, you will also come up with this number yourself. So I think 9 is the best option here. First of all, it is valid. Why? Because we learned also that if I have a divisibility relation, let us say that a divides b, then if I want to, I can multiply both sides by an integer m, and I can conclude ma divides mb, but I can also multiply only one side, provided that one side is only the right-hand side. So I can keep a the same, and I can multiply the right-hand side by n. So if this is true, and this is true. Of course, the first one will not be useful for me here, because if I multiply both sides by an integer, I will change 11, but in what I want to prove, I need 11. So it is not a wise choice to multiply both sides, yes? So I will multiply the right-hand side. Of course, I can multiply the right-hand side by infinitely many possibilities. I can multiply it by any integer, but probably not all of them will work. So I have done some trial and error. 9 will work here, okay? So let me multiply the right-hand side by 9. So then what happens, it becomes 18a, and then it becomes minus 27b, okay? So I multiplied the right-hand side by 9. The reason actually 9 comes to mind is not very hard, because you see that 18 that I generate after multiplying by 9 differs by 7a that I need by 11a's. So this means that, and then 11a is a multiple of 11, and according to this part of the theorem, I can eliminate that one. So it is not really hard to even guess number 9. Okay, so now you know the idea. So what I will do, I will continue and write 11 divides. Instead of 18a, I write 7a that I need, but to compensate for that, I have to add 11a to it. So instead of 18a, I write 7a plus 11a. And then instead of minus 27b, I need minus 5b. So I would write minus 5b, but to compensate for that, I have to write minus 22b as well. Okay, now you see that 11a is an integer multiple of the left-hand side. According to this direction of the theorem, I can eliminate that. And minus 22b is also an integer multiple of 11. 22 is 2 times 11, or minus 22 is minus 2 times 11. So this also can be eliminated. And what is left for me is just 11 divides 7a minus 5b. So if I start here, use this part of the theorem from lecture number 2, and then use this theorem from lecture number 3 together, I can understand that this is also true. I'm not saying this is the only way, but as I told you, that I want to use the theorems that I have presented in the previous lecture so that you can practice on them and you improve your skills in using them. Okay, another idea is, usually, which is a good one, we will talk about this later in this series of lectures when we when we want to talk about modular arithmetic. One good idea is to make 2a 1. If this coefficient, choose one of them, for example, let us work with variable a, what I will do, I will ask myself, which number should I multiply the right-hand side by so that when I take the multiples of 11 away, only one a is left, which is very simple. That number is 6, yes? So what I do, I would say that 11, according to the assumption, divides this. I multiply the right-hand side by 6, so this becomes 12a, and then that one becomes minus 18b. Okay, but again, according to that idea that we learned, instead of 12a, I can write 1a plus 11a, and then minus 18b, for example. I intentionally don't touch the right-hand, this second term. But 11a is a multiple of a, so that can be cancelled. Then I have this 11a minus 18b. I'm not saying this is the best way, probably that one was the optimal way to do it, but that's also okay. The point is to make the coefficient of one of these variables equal to 1. Okay, and then I ask myself, what do I need? I do not need a, I need 7a. Okay, then I multiply everything by 7. So 11 divides, I only multiply the right-hand side by 7. And if I multiply 7 here, it becomes 70. And this one is 126 B's. Okay. Okay, this is what I have. This is good because I have 11. I need 11. I have 7a. I also need 7a. But I do not need 126 B's. Okay, what I need then is 7a, I copy and paste, but instead of 126b, I write minus 5b, yes? But what should I add? I want to go back to minus 126. I have written minus 5 here, so I have to write minus 121b here, okay? So, and then you know that 121 is an integer multiple of 11. 11 times 11 is 121, so again, according to the theorem, that can be eliminated, and I get my result. Yes, so that is also possible. So I'm saying that if you can find a number, as I described here for you, 9 was the best choice here, but you can always also solve the problem in 2 or more steps. Both of them are correct. Okay. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.